Great. All right. So, as you know, you're here today to hear about how to set your engineering team up for success with AI. We were really excited that Pete said yes when we asked him to lead up this topic. I have known Pete for years, but in the nature of things these days, I only got to meet him in person a few months ago in Seattle. And Pete has blogged prolifically for quite some time, but particularly over the last few months, I have read, I think, every single one of your blog posts at this point, because he's been sharing such rich content. Yeah, yeah. Good job. Thank you, Pete. I mean, thanks for helping me learn new things. But he's been writing a lot about his own experience with wrangling AI to get it to do what we want it to do, but also how to think about rolling it out within your organization. And I'll do the formal bio in a second, but what you'll hear as I go through this bio is that Pete has had experience at many organizations going through different types of technology transitions, much like the one that we're about to enter with AI. So he's bringing all that knowledge into this current challenge that we have in the current transition with AI. So a little bit about Pete. He's based in the Pacific Northwest. He's got more than 2 decades of experience in building software and guiding development teams to success. He is CTO at PartnerSlate and is also a founding member of the Open Feature Governance Board at the Cloud Native Computing Foundation. And he's also worked at other organizations you'll have heard of, like Earnest, ThoughtWorks, and more. And something that I've seen is that he's really passionate about providing mentorship and assistance to engineering organizations who are exploring emerging technologies of all kinds, be it AI or something else, and helping them adjust their engineering practices as they scale. So that's it for me. Pete, we're really excited to hear from you.
Yeah, lovely to be here. Okay, I am gonna dive right in and share my screen and get started. Um, Now, can you see the slides?
Yeah.
Okay, great. So we're here to talk about AI assisted engineering. What a time to be alive in 2025. So as Lauren said, I've been in the software business almost about 25 years now. And I can kind of honestly say I don't think I've seen like such a wild technology adoption as we're seeing with AI. And I've definitely not seen like such a hyped up technology adoption as we're seeing with AI. There's these kind of pronouncements from people about all of our jobs are going to be replaced by AI or half of our jobs are going to be replaced by AI. Um, it's interesting to note that I think most of the time the people making these pronouncements have a vested interest in more AI being adopted. They're the CEOs of the AI labs, or they're a startup building something on top of AI, or they're VCs that are heavily invested in AI. So I think it's worth taking a lot of this stuff with a little bit of a grain of salt. Just recently, we're starting, I would say, to see some of that kind of backlash from that hype already. There was this report from MIT that kind of like in the enterprise, maybe turns out that a lot of this AI stuff is not working out as well as everyone had kind of first hoped. Um, maybe we're already entering the trough of disillusionment. It kind of feels like we're kind of speed running through the Gartner hype cycle here. We're only kind of like 2 years into this kind of new technology, and we're already in this trough of disillusionment. And I'm kind of, in general, I am also a little bit in that trough of disillusionment. If you think about the kind of pronouncements that people were making 2 years ago about how much of an impact AI was going to have, we're not there yet, I would say, in terms of like societal impact or impact in our kind of business, in our work. Um, there's a lot of there's a few places where I think there's a lot of stuff happening, and there's a lot of places where actually it kind of feels like the world has not changed that much. One of the places where I think things are changing is in our world, software engineering, building software. I think it's really hard to argue at this point that AI isn't going to have like a really significant, serious impact in how we build software. Even if all development stopped today, I think you'd still say that the way that we build software now is different, in good and bad ways, but is different than it was before this Pandora's box was opened. So yeah, I think it really is having an impact in software development, and I think there's perhaps even more breathless hyperbole when it comes to AI assisted software engineering than in general. So you've got all of these kind of startup CEOs talking about how X% of their code is being written by AI, or X% of their engineers are using AI every day, or like this entire company was built without a software engineer ever writing a line of code. And when I talk to engineering leaders, this is the thing that's kind of keeping them up at night. And it's not like, oh my gosh, this crazy stuff is happening. What I hear a lot is, I've tried this stuff out myself. It's really cool, but like I don't see how like it's like there's some disconnect between my experience of using these tools versus what the CEO of this startup is saying, or what I'm reading in this Business Insider post or this Forbes article or whatever. Um, so I think it's worth kind of taking a reality check around all of this kind of hyperbole. So first of all, I think there's a big distinction between AI authored code versus AI authored software. So when a startup CEO is pronouncing 60% of our PRs are written with AI, or 25% of our code is written by AI, that could well just mean like there's an engineer and they're hitting tab on the Copilot completion, and that's kind of AI authored, right? And there's a big distinction between that, where an engineer is very much in the loop, there's a human very much in the loop guiding the process, versus a PM vibe coding a feature and like it just goes straight out to production without a human. So I think that's the first thing that I think is really important to be aware of when you're reading a lot of this hyperbolic statements. Also, we live in 2025, and there's the algorithm, and the way we consume media has really changed. And so just this like stuff that's hyperbolic just gets a lot more attention. We're not hearing about the boring kind of normal stories of like, oh, it turned out we did this and it was okay, but it wasn't that great, because that's not something that gets boosted by the algorithm. And the last thing, and this is like I think something that Lauren and kind of folks that know more about this kind of stuff could talk more about. It's interesting to note that most of these claims really focus on adoption and not impact. So the startup CEO is saying 50% of our code is written by AI. Great. They're not saying our engineers are 10x more productive. I was hearing that more like maybe a year ago, and I've noticed in the last 6 months or so, that's less the story that people are telling. Even these kind of like boosters of AI, they're not really saying that. And I think part of that is the actual kind of scientific studies that are being done around impact, like how much is AI affecting our productivity, are, I would say, mixed. I was when I met up with Lauren in Seattle, one of the things I was saying, joking about, is that if you're pro AI or anti AI, there's a study for you, right? You can just find a study that says productivity went up 10% or went down or whatever. Like it's a mixed bag, and it's really hard to actually understand what the impact is. So lots of noise, lots of hyperbole. The impact is maybe we're not quite sure yet. And then the last thing I'll point out around this is, so this is a survey that this person Angie Jones did. She's like this really awesome kind of like DevRel person and thought leader who's been in the industry for a long time and kind of like maybe skews a little bit more towards the enterprise. She asked people like, who's paying for your dev tools, your AI tools? And it's just really interesting to me that over a third responded that basically their company is doing nothing to with AI. Like when I read this, when I see the survey, what I see is over a third of these people are working in a company that hasn't even started rolling out any kind of AI adoption program, because these people are kind of like on their own. And I would guess that these respondents are still kind of like somewhat ahead of the curve of adoption of just the industry in general. I think that yeah, I think that like they're the kind of people who are on Twitter respond on tech Twitter responding to a kind of like an influencer type person in a survey. They're probably like a little bit ahead of the curve. So I think the story of the industry at large is actually that people are just getting started figuring out how to use these tools. So this kind of FOMO and gaslighting of like, oh my gosh, what everyone else is already like getting 10x improvements is not, I don't think it's actually really that real. So then, okay, so the question that I get asked the most when I'm talking to, a VP of engineering or a CTO, something like that, is like this question, is AI assisted engineering really that big a deal, or is it just hype, right? And my answer is kind of like yes, right? Like I I do think it's a really significant change in our industry, and I think there's potential for it to really significant improvements in impact in productivity. But I also think there's a ton of gaslighting, there's a ton of FOMO. But yeah, at the end of the day, I think it is a genuinely transformative moment, and whether you're whether you're a booster or not of AI, it's kind of your responsibility to take this seriously. And honestly, even if you think it's not a big deal, your CEO and your company's board of directors are experiencing the exact same gaslighting and FOMO that you are. And the way that they're going to respond to that is by asking you, hey, like, what are we doing with AI? So it would be nice if you have a plan. If you haven't already had this question, or even if you had. So the way that I think that you should respond, I think the best way to respond to that kind of question from a C-level exec or a board is to have a clear plan with some data that lets you track progress. So that's what I think these leaders are looking for is when they're asking someone kind of low down in the org, like what are we doing? They want some confidence that you've actually got a plan so they don't have to get in the weeds and micromanage it. They want to know that you've got it, and they want some feedback loop to understand how things are going and are you making progress. I think this is what we need to have ready for us, ready for our executives when we're talking to them. So there's this question, what are we doing with AI? And as Lauren kind of hinted at, this is very similar to a lot of the other questions that we've kind of been asked over the years. So I've seen kind of like all of these ones. Java was actually already kind of a thing before I started the industry, but like, you know, in some ways, this is the same uh, game we've been playing over and over again of kind of like transformational technology shows up or a big organizational transformation is needed, and we need to figure out how to respond to it. And I think to me, when I think about AI and the adoption of AI engineering, it's about 70% the same as all these last kind of waves of innovation and technology adoption, but there's some differences. So I'll talk first about what's the same. So when I think about how do you tackle adoption of a new technology or organizational transformation, changing your org, the way that I think works best is aligned autonomy and mission command. So set a clear goal for your teams. Give your teams clear metrics on where you are. Like here's where we are today. Here's where you need to get to. Here's where you are like next week, and then empower your teams to do the work, right? So you align your teams around a goal, and then you give them the autonomy to move towards that goal. But then you're also providing support for those teams along the way. So this is like sometimes called like mission command. Like you describe the mission, the overall objective. The people who are on the ground actually understanding how things are working and trying this stuff out get to decide the tactics of how you implement that mission. And this is how you would roll out DevOps, or this is how you would roll out, Agile or microservices. There's like this stuff is I think a very similar playbook, but there's some stuff that's different. So I think AI is different because it is this genuinely novel, really weird technology. It's extremely unintuitive. There's kind of this alien brain. What AI is good at and bad at is not clear at all. And it's on top of that, things are changing and evolving really, really fast, like way faster than other technology transformations, I would say. And there's way more noise. So it's like this weird thing that doesn't make sense. The whole environment is shifting all the time, and there's a bunch of people saying like, "Oh, I found this one weird trick. If you do this, then it gets 10 times better," or if you do this, then it will never work. So it's basically just a lot of stuff all going on. If you're a systems thinking person, there's this framework called the Hennepin framework, which I won't have time to go into, but basically what this talks about is depending on how much like understanding and how much kind of relation there is between cause and effect in a system, you kind of behave differently. And I would argue because of all that stuff I just said about AI being this kind of weird technology and things are changing really fast and there's a bunch of noise, we're in this kind of firmly in this chaotic domain, where the best way to respond is this kind of idea of novel practice. So rather than kind of like formulating a plan and then executing on the plan, It's more like you're in this kind of responsive loop where you kind of try a thing, see what happened, and then decide what the next thing is you want to do. So sometimes also a little bit like an OODA loop if you're into other systems thinking stuff. But basically, there's so much unknown here, and the connection between what you do and the outcomes is so hard to understand that the best thing you can do to succeed in this environment is just start doing stuff and figure out what works and what doesn't. I think in the context of adopting AI, what we want to get to, like I said earlier, is impact, right? What we want to get to is increased productivity, better return on investment, more money made, happier engineers, happier customers, whatever. That's the impact is what we want to get to. But I think people that start by saying, let's start measuring, let's set a goal around impact and start measuring impact, it's it's too chaotic, it's too unknown to start there. What we want to start with is establishing a really good culture around experimentation and just start using the stuff and figuring out and getting past that initial kind of weirdness of like we don't know what the heck is going on to the point that then we can start adopting the technology and then we can start talking about impact. But I don't think we should be jumping straight away to impact. I think the first thing to do in such a chaotic environment where there's so much stuff changing so fast and it's so unclear what works and what doesn't is to start with this culture of experimentation. So, if that's what we want to do, how do we make that happen? We set a goal and we define metrics. So, in the context of experimentation, our goal might be by the end of this quarter, every team will have tried at least 10 different experiments in using AI for day-to-day work. This is not the goal you should use. I mean, you can try, it might work, but like, you're going to want to tailor this to your organization. But this is the kind of thing I'm talking about when I'm saying set a goal. Um, when you're setting goals, there's this whole kind of thing of if you want to empower autonomy, then you want your goal to be in this kind of Goldilocks zone where it's not super vague, like telling all your teams, hey, we want everyone to be using AI. That some people are going to be using Cursor, some people are just going to be using ChatGPT to write emails. You're not going to get any alignment and you're not going to make much forward progress. On the flip side, telling everyone we should be using this specific tool, this team should be using this tool, these other teams should be using this tool this much, that's too prescriptive. You're not giving people, your teams, autonomy, and the ground is shifting so fast, and our understanding of what works and what doesn't is so unclear at the moment that you really don't want to be setting this kind of prescriptive guidance. You want to be giving your teams a broad objective and then letting them figure out how to make progress towards that objective. So metrics. So here's some examples of maybe some metrics that you would use. The overall thing here is you want to have some objective measures that let you know how you're tracking towards that goal. So figure out what your goal is and then figure out what the metrics are that let you know if you're making progress to that goal. These are metrics that your teams can use. You can report them back to your team so they know, are we heading in the right direction or not? And they're also metrics that you can play back up to your leadership so they know overall how are we progressing as an organization. Again, your metrics are going to vary. These are some examples of what I think kind of makes sense for experimentation. And note that these are really different from the metrics you use for impact, right? We're not looking at kind of like what's the size of the average size, like wait time for a PR or something like that. Really what we're focused on is metrics that define the behavior that we want. The behavior we want is teams using this stuff, understanding it, talking to each other. And so that's the metrics that we use kind of help our teams understand that that's the direction we want to go. And like I said, we want to kind of give our teams autonomy to get towards that goal, but we also want to provide support along the way. So let's talk about like what kind of support you would want to provide. There's a lot of different types of organizational support I think you should be providing for teams as they're adopting AI. The two things I think are particularly valuable in this context is kind of training and communities of practice. So training in general, engineers are pretty skeptical of training. I'm pretty skeptical of training. There's this kind of thing where you just kind of show up and like rub a trainer on it and then kind of hope it works, and it doesn't really work. AI, I think because it's such a novel technology and it's so unintuitive, I do think there's value here. When I talk to real engineers in the field, not like the people who are tweeting about this stuff or writing LinkedIn posts about it, but the average engineer who's just trying to get their job done, they still like there's some fundamental understanding of like what an LLM is and like where does it get its knowledge from and what does it know and how does prompts work and how does context engineering work that a lot of engineers just don't have. And that's kind of a foundational thing you need if you're going to be successful using these tools. There's a lot of engineers that I speak to that are still like, as far as they're concerned, AI assisted coding is like Copilot and tab completion. There's this whole new kind of breed of tools around agentic coding and vibe coding that are really quite different. They work different. They're useful for different things. And getting just everyone on this on a foundational knowledge of like, hey, there's all of these different tools that you could be experimenting with is just really important because otherwise everyone's just going to experiment with the stuff they know about, right? Well, not everyone, but some people are just going to think that that's the entire world when there's this a whole other world around them. And although this is like super fast moving and novel and all the rest of it, there are some kind of like best practices around working with AI that I think have already emerged. And your engineers will eventually figure this stuff out. They're smart, they're really good at learning, but why not kind of give them a little bit of a shortcut and just teach them some of the foundational things out front? So I'm generally skeptical of training. I think it is useful as part of supporting this journey for engineers. I'm not going to have time to talk through all this. So I wrote a blog post about a lot of this stuff. This is an example, kind of like syllabus for that kind of foundational training. If you want to know more, kind of like read the blog post, I guess. Um, and then last piece around communities of practice. So again, like more, I think more so than most of these previous waves of technology adoption, um, it's such a chaotic, poorly understood um, landscape that the best way to figure out what to do is to do stuff and then talk to each other about what you're doing, right? So like having teams try stuff out, tell other teams like, oh, I tried this thing and it didn't work, or I tried this thing and it's worked really well, or I found this really cool new tool in the context of my organization, right? Like, hey, we have this really weird system here. I found this tool doesn't work with it at all. Or, how we have this internal support team, they've started to use this tool and it's working really well. So establishing that kind of connective tissue of folks on the ground who understand the problem, talking to each other about how to kind of solve the problem is really valuable. Communities of practice is kind of a way of doing that. I think in general, like COPs can kind of have a bit of a bad rap, particularly in larger organizations, in my experience. What I often see is they start off with some fanfare, and then there's some kind of like a lot of engagement at the beginning, and then they kind of fizzle out, and then like a year later, there's like two people showing up to a meeting every 2 weeks. Um, that's not going to cut it for this. And this is a long game that you're playing in terms of like building this organizational DNA around AI. So I think more so than other waves of adoption, you should be providing like a solid amount of top-down support to make that community of practice work, like a kind of super COP where it's literally someone's job to make sure that engagement is there, and you're measuring metrics around engagement with the community of practice. Like you're giving again, setting a clear goal, like this community of practice being a working like vibrant thing is a clear goal that someone has, and they've got metrics to know whether they're tracking towards that goal. Um, when I was researching some of this talk, I actually noticed that you don't have to just take my word for it around transformation. So I found this stuff from the Dora State of DevOps report from 2019. So Dora, famous for the Dora metrics, the book Accelerate. They also did this State of DevOps report for years and years. It kind of was the foundation for a lot of their work. In 2019, they talked a lot. They kind of focused a lot of their report on how do we do DevOps transformations. And like I said, DevOps transformation, AI adoption, a lot of the stuff works the same. One of the things they found I thought was really interesting is that elite performers tend to use communities of practice plus top-down support to achieve their goals. So not just me saying it, these people used science and stuff. And on a more serious note, I really encourage you to download the 2019 report and read some of the stuff in there around transformation because it's super, super relevant for this stuff too. There's also some kind of guides that Jez Humble and other folks have written specifically around how to do transformation. And most of it applies in this context too. So in summary, like there's just a crazy amount of hype around this stuff and gaslighting and FOMO. It's really annoying, but it's also like got real potential to transform or at least really impact how productive you can be as engineers. And I think you kind of owe it to your teams and to your boss to to really seriously invest some time in trying to make this work. My belief is eventually we're all going to figure it out, but you kind of want to like get ahead of the game here rather than in 2 years' time be one of the laggards that's finally figuring out how to get their teams to use this stuff. Like many other transformations, I think the key for this is top-down support that's driving this bottoms-up grassroots change. And really, because it's such a crazy technology, experimentation is the way to start. Like the theme here is it feels really new and different, but in many ways it's the same as many of the other transformations we've gone through. Uh, we got through the last one, we'll get through this one. You got this.
Amazing. That was so sick. I hope everyone found that really useful. Thank you again for dropping all the helpful links to the blog post, Miller, for Pete. And also, if you want to read the Draw report for 2019, it's over here. Put it in the chat as well. We're going to have some questions for you now, Pete, which will be recorded. So if anyone has any last minute questions that they haven't already sent in via HubSpot, please drop them in the chat and we'll read them out. But we do want to also save time for the breakout rooms activity, so we're going to limit questions to maybe about 5 minutes or so. And if you're available, you can stick around at the end to ask Pete more questions post activity. Um, cool. So we've got a couple of questions here. I'm just going to read out one which actually I think multiple people sent in, all worded very similarly. Maybe they were all using uh, ChatGPT to write them at the same time. But one question that came up a lot was people were asking about how they could build frameworks to enable junior engineers to use AI effectively. And also, essentially, how can you help junior engineers develop technical skills and avoid adding AI rubbish that poisons code repositories? I'm quoting directly from the question.
I mean, so I think it's a real challenge. I think there's two things mixed up in that question. Maybe there's this kind of thing of like how do you like make sure that you're not getting a bunch of slop in your code base, um, which I think can be happening maybe from junior engineers, also honestly from like other engineers and probably from designers and PMs and the CEO who's found some tool that lets him kind of like commit changes to the code base. So I think that's one thing. I think there's also a question of like how do we continue to mentor and grow junior engineers? I think for that second one, the how do we kind of mentor and I think it's not that different than how we've generally like mentored and grown junior engineers, like pairing them up with senior folks, setting up really good feedback systems, supporting them, giving them like explaining to them that their job is to learn, not to produce code, at least at the beginning of their career, like all that kind of stuff, I think is just kind of the same. Um, the stuff around kind of protecting our code base from junior engineers or from AI, to some extent, it's also kind of the same, right? Like 5 years ago, we had junior engineers who just joined the code base who had the potential to do bad things. What did we do? We partly we reviewed the code that they were writing, but I think also a lot of it is around the systems that you the systems that you set up around your code to ensure the quality of your code. This is, I think, there's some like I think really high performing teams have had this stuff in place for since Jez Humble wrote the continuous delivery book. So what's that, like 15 years ago or something now, 10 years ago. These idea of like make it so that it's hard to, like your kind of your code base has a self-healing quality where if someone writes bad code, the tests will catch it or the linting rules will catch it, all that kind of stuff. I think we just basically need to take a lot of those ideas that are already kind of well known to be a way to make your teams more high performing, but they're just much more important now because you need to protect yourself not just from um, an engineer who's in a rush, but an engineer who's using an AI to produce like a really ginormous PR. I think also like the other thing that I think is important when it comes to kind of protecting from slop is having um, some clear rules as to what's acceptable and not in terms of submitting a PR or a code change. Like you should be accountable for the code that you wrote, that you're submitting, and you should be vouching that this code could go to production. I think is a really good rule of thumb. And when I say that, a lot of engineers are like, well, yeah, duh. But other engineers are like, yeah, I guess we've never really said that out loud. Um, so I think like making that clear and saying, there needs to be someone who's accountable for the quality of this code. And when you're saying, I'm ready for this code to be reviewed, you're saying like, I know what this code does and I'm confident that it works, rather than just like, I don't know, the AI did it, but can you review it, please? That's not really acceptable. And I think you just need to set a really hard line for your team of like, that's not okay. Like my job is not to review your slop. Like your job is to review your slop, and then I'll review it after you've reviewed it, right? Like, so I think it's a lot of it is, I mean, again, kind of going back to the theme of the talk, like a lot of it is using the same stuff that we've done before, but there's a twist in kind of maybe have to turn some of the knobs up to 11 because the pace at which people can produce code is so high and the quality of the code is not good. AI is not great at writing code.
That's awesome. Thank you so much for that. I see a couple questions rolling in the chat, so I'll take one from the chat before going back to the pre-submitted ones. I think a good one is probably from Chris. Thanks for sending in your question. Says, how do you approach training for a group of developers with a mixed level of experience with AI
Mhm.
tools? Some are just autocomplete, whereas others are using multiple agents in parallel.
Yeah. I mean, I think it's a good question. I think to some extent the right way to do it is to set up like kind of a 101, 102, kind of 201 type thing where you've got like a cohort that are just if you've got a cohort that are using, like in your example, Chris, like they're using kind of multiple agents in parallel, you definitely don't want to have force them to sit through this is a coding assistant, let's get it installed. So I think it's kind of like setting up a syllabus where you've got different things for different people. I do think that there's some foundational stuff that I think particularly actually with this technology, because it's moving so fast and because a lot of people are like seeing stuff that other people are reading and being like, oh, cool, that's cool. I have seen a lot of engineers who are doing really advanced stuff with the tooling. Like they've got these agents running and all the rest of it, but they don't have a good like internal model of like what is the actual how does the LLM get context? And I think the biggest thing for succeeding with coding agents is understanding context management and constraining like what the AI can do so that it kind of falls into the pit of success. And what I've seen is even people who like necessarily like using those really fancy techniques, sometimes they don't have that foundational knowledge of how do I kind of prompt properly and like why should I not have 25 MCP tools um, configured. So I think you don't want to kind of drag everyone through the really, really fundamental stuff, but I think there's kind of some foundational knowledge that you do want to make sure that all of your engineers understand, mostly around context. I think the more I work with these tools, the more I realize the key is like really grokking like how context works for the LLM and like what it's working with and what context is it using. Yeah, like Vivek said, context rot is real, context poisoning is real, like it's a real thing, and like it's something that I think you need to play with the tools and try different things out and like really get your head around how much that impacts it.
Thanks for that. In the same vein, another follow-on from Ross, I think, given that we think context is super important, it has to persist. What are some other technology and people principles that most of us believe in as devs that persist regardless of how we're building our tech? And in the same vein, what current beliefs can we let go of in the AI age? Ross said
Mm.
documentation, question mark, code readability, which I know is a joke, but that gave me shivers when I saw
No,
that.
no, I don't
So,
think
you
it's
know.
that's a serious thing that people are asking. So okay, so I think like in the spirit of the kind of chaotic Hinefin domain thing, some of it I don't know. Like I really think part of it is experimenting with what would happen if we put all of our code in a single file. What would happen if we, like, and that's the kind of like weird experiments that some people are doing. I do think that there's the thing that feels like it feels like there's a real theme around um basically focusing on all of the stuff that you would do if you were constantly onboarding junior engineers. So really good onboarding documentation is something that we probably should have had for a get-go, and like and a code base where there's a like knowing how to run the linting and the testing and the internal code quality is always just a single script. It's something we probably should always have for every code base, but we don't really bother if we're not, if the team is kind of fairly static and we don't have new people coming in all the time. But thinking about what would we do if we wanted teams outside of this, the team that owns this code base to contribute to this code? Or what would we do if we were in hyper growth mode and we had new junior engineers joining the team every week? I think that's a pretty good rule of thumb. Though the stuff that you would do that would help in that context is generally going to help the coding agent, which is basically like a new engineer that shows up every half an hour, right? Like every half an hour, you're clearing the context because context managing your context is a really hard thing. So every half an hour, like the goldfish agent is like, all right, so what's the nature of your business? Like literally, like they haven't, it has no clue. It has absolutely no idea about your code base, about like what the product is, what industry you're in, anything. And so you really just have to be just welcome back, Dave. Like here's the onboarding docs. And yeah, so I think that's a lot of it. And another thing that I've been thinking about a lot recently is um, not rubbing more AI on it to solve AI problems. So something that I've been thinking about a lot is linting rules. So you could have in your agent's kind of like rules file, in this code base, we use semicolons at the end of our lines or whatever, and that would probably work most of the time. But instead, if you write a linting rule that does that, um, the linter is way better than the AI at actually following that rule. It can deterministically follow it every single time, and you can still give that feedback loop to the AI that lets it know, oops, I did that wrong, and you're still gonna get the same effect, but you're not like leaning on AI to do stuff that it's actually really not that good at. So something I've been thinking about a lot is like, how do we remove like lines and lines and lines of instructions of like, we prefer to do it this way, and don't forget that in this place we run the test first, and just have the system force you to do those things, just like you would have a junior engineer have the system be like on a really good code base. You rock up to the code base, you run the single command, and it won't let you do the things that the team doesn't want you to do because they've baked it into the system rather than having it be a bunch of kind of tribal knowledge that you have to read in the README and no one reads the README.
Thanks for that. We'll give you one last question. And also I see Chris is dropping. Thanks for coming, Chris. Really appreciate you coming. And everyone who's dropped off so far because of work stuff, thanks for coming to this little bit. But we'll have one more question here that will be recorded, and it's also because we've got maybe 4 or 5 people asking about this, and it's specifically about what are some adoption deterrents that you've seen on teams to adopting AI. And also, we had a question from someone earlier in the chat who said that they saw resistance from developers in using these new tools. And if you have any insight into why there's this fear or resistance in teams, and also how to reduce it in your experience.
So the fear and resistance, I think that's multifaceted. I think at some like very like true deep emotional level, some people are scared about losing their jobs. Like I think I there's an element of that, and it's really and you've got to kind of like, I mean, when you're talking to engineers about it, you can't be flippant about this stuff, and you've got to embrace that that's the reality for some of these people. So I think that's part of it. I think there's also the grumpy senior. I was this person, I don't know, a year or so ago, the grumpy senior engineer that tries out Copilot and like, like, yeah, great, like it knows how to do a for loop, like no big deal. And if you haven't like again like it's such an alien technology and it's so unintuitive what it's good at and what it's bad at, that if you if you happen to use it in a way that it's not, you see it being really good at one thing, like, oh my gosh, this thing knows every programming language under the sun, and then you see it being like really bad at other stuff, and I think a lot of engineers just kind of try it and they're just like, this it doesn't like it's not good, like it doesn't work, like it's a senior engineer but it can't do senior engineer things. I think you again, going back to the experimentation part, what did it for me was literally just spending a week just forcing myself to use a coding agent for everything. Or maybe it wasn't a coding agent because I don't think they were really around, but like forcing myself to use Copilot for everything. Um, and starting to internalize what it's good at and what it's bad at. I think once you get past this hump where you realize like, oh yeah, it's really, really bad at software design, And I wouldn't trust it to do any kind of good things with software design. But like doing just a tedious refactoring like in 20 different places, it's amazing at. Or like busting out a greenfield prototype, it's like 10 times faster than I would be. Or writing SQL statements. It's always going to write better SQL than I can because I'm not very good at writing SQL. So figuring out what those sweet spots are, I think is the key for getting those kind of grumpy senior engineers over and being like I think engineers, particularly more seasoned engineers, have naturally have a very healthy skepticism towards new stuff and kind of have a lot of healthy skepticism towards hyperbole and like influencers that have like a YouTube thumbnail like type thing, right? Like I think we have a natural allergy to that kind of thing, and it takes a while to realize that, yeah, there's a bunch of that BS, but underneath, there's actually some really useful things. And it kind of irritates me a lot that there aren't that many people that are taking that middle pragmatic path and saying like AI is really bad at this stuff. Like it's not going to be good at this, but it's really good at this stuff. Everyone, it feels like everyone's kind of like retreated to their either side of the chasm. So yeah, that's kind of part of what I'm excited about is kind of trying to meet people in the middle and talk about the stuff it's good at and the stuff it's bad at.